Okay, here is the pendulum experiment we discussed the last time. We derived this expression for the speed of a pendulum at the lowest point. If I know the length of the string and the release angle, right? So as I said, we can do this experiment. So I do have a pendulum set up here. So I have a photo gate, right, at the lowest point to measure its speed. So we can confirm, we can compare this experimental value with our expression. So first of all, let's measure the length of the string, right? This is the string. I'm going to measure the length from the center of mass to, so that's 38 centimeters. So the length I plug in 0.38 meters. Right. So now let's pick some angles so we can test our theory. So say if I choose 10 degrees, I can always release that at different angles, right? So I want you to use a calculator and then find this V. Okay, then we can compare it with the experiment. So if we use a 10 degree, what do we get? So my prediction would be this, 0.336 meters per second square. Okay, we can pick a different angles. Let's say I pick another angle, 20 degrees. What's going to be our prediction? We're just going to try these different angles, like 20 degree. Let's plug it in. So our prediction, my prediction is this. And then let's try another one, like say 30. So what would be our prediction? Let's see. Okay, so that's going to be almost 1, right? 0.999, so let's call it 1. Okay, so these are our predictions. So let's now, I've already hooked it up with my laptop, and you can see the capstone software on the screen. So it's going to measure the speed of this pendulum at the lowest point. So you can show I can see the measurements on the screen. So now I'm going to hit the record, and then how do I make sure I get the right angle? So there's a protractor attached to this rod. So actually I already placed this line, okay, right at 90 degrees. So all I need to do, if I want to say release at 10 degrees, well, it's a little bit, I think it's hard for you to see. I just need to pull it to 100 degrees. So the difference is 10 degrees, I release it at 100. If I want to have a release angle 20 degrees, I pull it at 110 degrees and then release it. So the difference, the angle is going to be at 20, okay? So we have this protractor here to help us find the release angle we need. Now I'm going to do the experiment. I'm going to start recording. Okay, I have already started. Now let's see, I'm going to pull it at 100 degrees, so the release angle is going to be 10. So let's see if we can get anything close. Okay, 0.35, that's our experimental value, very close. All right, let's try 20 degrees. So I'm going to pull it to 110 degrees, and again I'm going to release it 0.7. So that's our value, right? So that's going to be, again, very close to our prediction. Now, of course, the velocity is going to go down because of a friction, okay? Now, let's try 30 degrees. Our prediction is 1, so let's see if we can get anything close to 1. Okay, 1.03, let's call it. So it's going to be again, very, very close to, in a real experiment, especially an experiment in the classroom, okay, these are very, very good results, right? You can see the experimental values are very close to our predictions. So that is how we use conservation of energy to predict the speed of the pendulum at the lowest point.